This is the town hall for grant round 7. We had like over 15 proposals, so that was like super exciting, and I'm really excited to see like what you guys have to share. Um, there's probably maybe 4 to like 6 presentations that may happen today, and which is really exciting. Just like I was mentioning earlier, it's like we get to go a little more in depth with each one, flesh out ideas. So that's always cool and fun. Depth is always good when we have the opportunities to do it. Yeah, so I think we'll just wait for 4 more minutes just to give other people a chance to come in, and then we'll get started.
I was hoping in this sort of phase when we're waiting, if anybody came across is it the Galactica model drama? It seems like there's always drama to talk about when we when we when we have these presentations. I haven't come across. I haven't read through anything. I don't know if people have read through it and have any idea what the drama is about.
I can, I guess, mention what the drama is if you want me to tell you.
This is great because last time you explained the drama about the Reddit, and it was great. Honestly, I think we should make this a tradition. Yeah, please do.
Okay, so the idea is that Meta AI made a state-of-the-art model, and they discovered that using higher quality data results in higher quality outputs, which should not surprise anybody. And to that end, they decided to train their large model on a corpus of scientific papers and books. And then they fine-tune that to give it some ability to instruct or command the model to produce outputs that you want, like a paper on the virtues or nutrition of eating Tide Pods, for example, right? And the paper, being a large language model, will make you a paper on the nutritional value of eating Tide Pods. So many people were really upset, and they're like, look at this, it only retrieves 40% of the citations correctly. However, this is higher than the average person using a search engine. So when I type in a topic like, nitrogen vacancy nanodiamonds for quantum computers, I'm going to get lower than that. I'm going to have to read through all the documentation and then quote mine whatever I want when I'm writing a paper. However, many people think that the real reason why people are upset is because some of the fields from which the complainers arose are fields that are non-falsifiable and do not make meaningful predictions. And there's a guy named James Lindsay and Peter Boghossian who did this grievance studies paper. And the grievance studies paper was, let's see what kind of papers we can produce and see if it can slide through peer review without anybody noticing. Things like the rape culture at dog parks and feminist glaciology, how we're penetrating the glaciers with our giant phallic drills. And I think that the real fear is that there's this non-falsifiable and this body of work that makes no real predictions. And there's no way to meaningfully filter out what's machine generated and what's parody. And so they started a giant, so they made a giant witch hunt to try to get the Galactica model taken down because of its ideas of the idea that it can create lots of harm. And then Jan LeCun had a Twitter exchange where he was trying to get people to explain to him what is the actual harm. Like, explain to me who has been harmed and under what circumstances people can do harm, and where that harm is any different than just a person using a word processor and literally just making up nonsense, like, the grievance studies papers. So there you go. That's the drama.
that happened. Humans like submitted some bogus papers a while back to some of these different fields. I remember that, and there was like a big thing about it. And it's like I even saw like Michael Black, like who's obviously in a field that does have falsifiable claims. He was kind of the issues that he brought up were that the references weren't correct and stuff that seemed like it was easily fixable. At the same time, I can see a case where you can fix the references and stuff and it could still like sound correct. But as long as it's falsifiable, I don't see what the issue is. I think like peer review system is like a little bit broken anyway. And if this kind of brings to the surface all of the issues with the peer review system, it's not the model's fault, right? It's the peer review system. So I don't know.
And I saw there was a post by Imad to see if there is a chance that he can bring it back, or they can bring it back under the licensing terms. I don't know if that would happen or if that's just a PR move. But yeah, it'd be interesting to follow that drama, I guess. Cool. So I'll hand it over to Ty. I think a lot of the folks have come in now.
Yeah. Awesome. Cool. So I think we should like just hop right on in. We have, again, like maybe like 4 to 6 different presentations, be able to go in depth. Robert is first and here. Hey, what's going on? Excited to see what you got going on.
Hi, yeah. Happy to be here. Let me just work out how to present my slides.
Sure.
On this. It's going to be interesting. Okay. I don't think I've used GatherTown once, but I've definitely not presented slides on it.
There's a button in the bottom left.
Yes, exactly.
Right. I will do that. Bottom left, this one that says screen share, I guess. Chrome tab, this. Cool. Can you guys see that?
Yeah. Awesome.
Great. Cool. Yeah. So this is just a short presentation about the grant proposal I did, which has this very lengthy title, which I will like break down a bit in this presentation, and then feel free to ask questions, during or at the end, of course. So yeah, I'm Rob or Rob. I'm a PhD student at UCL, supervised by these people, but you may not. It's no worries. I'm doing like generalization, reinforcement learning, alignment, and safety, and this kind of project, which the grant is concerned with, is kind of in some sense the intersection of all of these things. So yeah, I'm asking for some money, or proposing this project about doing human evaluations for reinforcement learning versus imitation learning as methods of fine-tuning large language models. Yeah, blah blah blah. So what's that about? So yeah, this first part, reinforcement learning versus imitation learning. So these are like 2 methods you could use to fine-tune a large language model. Reinforcement learning is kind of probably the technique, but they used, it's definitely the technique, but for example, OpenAI used for InstructGPT or these other kind of methods. You have a reward function, you optimize your policy to like maximize the reward. Imitation learning is basically the same as supervised fine-tuning. If you consider the kind of the input-output pairs that you're given as like effectively demonstrations from an expert. And then, the key differences in some sense, like where is the supervision signal coming from, like what part of this is telling you what to do. And in reinforcement learning, you have this reward function that says like, this output was good, this output was bad. And in the imitation learning, you just say like, these are the outputs you should be doing. Yeah, and so there's these large language models. I guess most of you are pretty familiar with it. Like someone was just talking about Galactica, which is this example of maybe a not very good one, especially within its domain. I'm focusing on kind of autoregressive large language models because it's like more easy to see how to fine-tune them with RL, and that's the style of models that has been used previously. And so these are the ones that just like generate text, like token by token or word by word. Yeah, I don't know why that thing is in there. So we can just go to the next thing. So we have these 2 methods for fine-tuning fine-tuning large language models, and I can like talk about the specifics of exactly how that works if people want. But we want to like compare like how well they do. But kind of the whole point of like these class of methods of fine-tuning these large language models is that we don't have like automated metrics. So we kind of need to use humans to evaluate like the outputs. So specifically, we're doing this summarization task, an example of which you can see here. And effectively, there's a Reddit post, there's 2 summaries produced by 2 models. Or like one of the summaries is the reference summary, effectively written by the person who wrote this original Reddit post. And that we're going to pay humans on this platform called Scale AI to rate the summaries using this kind of like this like confidence scale here that you can see on the right. So between -4 and 4. They'll see more stuff than this, and we'll receive instruction and training on like how to do this. Otherwise, it can be quite subjective which summary is better, obviously, especially when the summaries are like both quite high quality. So concretely, I've been training a series of fine-tuning a series of OPT models on this Reddit post summarization task with supervised learning and reinforcement learning. We're going to evaluate kind of the standard performance like on similar posts to what it saw during training, and also kind of out of distribution performance to see like how well it can summarize news articles. And also if we train, we'll train like another set of models on like just specific subsets, for example, like r/relationships, which makes up about 50% of the data set, and then see whether a model just trained to summarize like relationship Reddit posts can still summarize other Reddit posts or news articles well or not. And like I think this last thing is these 2 like out of distribution tests are like in some sense the more important ones, because these models, you're never going to be able to get the full correct distribution of data to train these models. And so what you really care about is like how well they're going to perform on like stuff that is quite unlike what they've seen before. And so like that seems to me to be the key metric to evaluate these 2 things. And for all of these, like when I say like evaluate in distribution performance or out of distribution performance, that means, generate outputs from the models on these inputs and then ask humans to evaluate these outputs. And again, as I said, this will be done by humans, and that's like where the request for the grant comes from. In terms of like what the project will deliver, I'm planning to open source the trained models and the code to train the model and all the data that I gathered from these evaluations, which should enable like future research. I may plan to do follow-up research and also be keen to like collaborate with people if they're interested in like this area. And then also like an academic paper and blog post and stuff which actually explains what the results were. So just to summarize, I'm working on this research project to compare reinforcement learning and supervised learning as methods for fine-tuning these large language models. To get an accurate picture of the performance of these methods, we need to use human evaluators of the quality of the output, and human evaluators aren't free. So that's what we're trying to do. Cool. Yeah. So that's kind of the project. Would definitely be keen to hear anybody's thoughts or questions or anything. Is someone waiting? Sorry, go on.
Well, I guess Tish raised his hand first, so.
No, go for it. I was just clapping. It was a good presentation. So yeah, go for it.
Okay. So I have a question, like what kind of evaluators are you using? Like, are these 6th graders? Are these college grads? Are they PhDs?
So they'll probably, so I think on Scale, which is this platform I'm going to use, you can set some requirements on, for example, their English ability or any domain expertise. I think it will just be people who can fluently speak English, basically, fluently speak and understand English, will probably be like native language English speakers. The way the Scale platform is set up is that you can create some training tasks at the beginning, which you've already labeled, and also some evaluation tasks mixed throughout the data labeling. And if any labelers are like not doing well, then they can be filtered out. When not doing well, we'll be like evaluating stuff very differently from how I would evaluate it, basically, or other researchers. So I should say, like, this is not just only my project. I'm like collaborating with other people on this thing.
Okay.
But I'm
And then,
the project, basically. Yeah. Go on.
and then I have like a couple of technical questions. So I understand that you're using, for instance, a scale of 1 to 4. Now, if you have like this summary, you have like 2 pairs of data sets, right? And your score is applying to like the entire process, not, let's say, the individual tokens. So, in a possible means of, is there a possible means of having somebody rewrite the summary so that the summary makes more sense? Like sometimes if like the grammar isn't right, and then you can either save that information and maybe use it for a future project, or if you, I don't really know how much you want to re-architect your code, but sort of like use one of like the, what is it called, masked language modeling, or one of these methods where you can project the loss to the individual tokens that are the ones at fault.
Yeah.
Then.
So I can answer like, so definitely that first method you described is something that exists in the literature, or some version of it. I haven't, like, I'm not planning to investigate that because it's like a lot more of an interactive process. But I'm definitely like doing that for future work. I expect so asking people to like write correct versions of the summaries is also going to be a lot more expensive than asking them to evaluate, as in per like summary or evaluation given. I'm definitely like curious to see like how methods like this, where there's more like natural language feedback that humans are giving, or like more interactive feedback, how they compare with these kind of methods where you just say like, just this is better, that is better, but don't provide any other information. I expect it like would work better, if it didn't matter how much humans cost, but like I'm uncertain whether like per human minute it would end up being better, basically, because it's going to be a lot quicker to just provide it. You're going to provide a lot more feedback if it's just pairwise comparisons rather than having to like rewrite the summary to be better.
And then I have a data set, and like I was before discussing high quality data sets, right? So I have a data set of, for instance, Supreme Court opinions, and a data set of the summaries of the Supreme Court opinions that are provided to, there's a university, and I'm having a brain fart because it's really late right now. But there's a university called, and it has the Legal Information Institute, and I think it's Cornell. That's right. It's Cornell's Legal Information Institute. They have summaries written by professional lawyers of all of these Supreme Court cases. I'm wondering if when you're doing your summarization, whether you could use like a more high quality corpus to maybe fine tune a model to do summarization better, and then also take inputs on the summarizations from the people.
So definitely using better or different data would produce a better or different model. I expect if you like fine tune a model on like this data of like summaries of court judgments, then it would be better at summarizing court judgments, but maybe worse at summarizing Reddit posts than one fine tuned on Reddit posts. I guess specifically the thing about the Reddit post data set I'm working with is it both has these reference summaries that we can do the supervised fine tuning on, and it also has human preferences that we can use to learn a reward function, which we can then use to do reinforcement learning on. Whereas if you don't have human preferences or some other way of capturing a reward function, then you can't do the reinforcement learning side of things. And like the project is designed to compare these things head to head. But I definitely would be curious to see like how well this method, like whether you can just slap it on this different data and it still works pretty well on these court judgments. I'm not familiar with the data set, but it seems interesting. Well, and you had a second part of that question, which I can't remember.
Oh, I asked about like whether or not you're creating a summarization engine, right? And there's already high quality summarizations. I tend to think of Reddit posts as less high quality than court judgments because of like the nature and training of the individuals using the rational judgment to do important work, right? That's kind of my thinking behind it. But I understand that it's content dependent. So maybe summarizing a Reddit post is different. Like there's jokes that court judgments are going to have, for example.
Yeah, high quality data is better, all else being equal. Probably court judgment data is high quality than Reddit posts because the people are taking longer to write the summaries and stuff as well, and like they're being paid for it, whereas Reddit users aren't. But so yeah, maybe court summarization trained models might generalize better or like continue to produce higher summaries in other situations than the Reddit post ones, or might not have pathologies that are present in Reddit post summarization, like people maybe not using the best grammar or like swearing or doing stuff that is fine on Reddit, but like maybe we don't want these models to be doing.
Swap Neil, looks like you have your hand raised. If you have a question, go ahead, and you'll be the last one before we move on to the next presenter.
Give me 1 second. So my question was just that do you have a sort of prior understanding of like roughly how many samples it takes to fine tune this kind of model? Specifically, like from a cost per post ratio, like how many posts is it going to be? Is the grant going to give you, and like is that sufficient to actually fine tune the model?
So the grant is giving me data just to evaluate the model. We already have the data which we're using to train the model. So I can answer the question for training and for evaluation. So for training, the data set we're using has for supervised learning has about 100,000 Reddit posts with summaries, and then for reinforcement learning we're going to use those Reddit posts without the summaries. The reward has about 60,000 pairwise comparisons between two summaries given a Reddit post. That's over about 15,000 Reddit post input because there's Reddit posts that have been summarized and on those summaries multiple times for the same post. For evaluation, it basically like the more money I get, the more evaluations I can do, and hence the more comparisons we can do. If I got a grand, for example, I would be able to do like quite a few evaluations. One evaluation probably costs about 10 cents. So 1,000 would be 10,000 evaluations. And if we want like 1,000 per comparison, then that enables us to do like to compare about to rate 10 different models, which would be pretty good. I'm planning to also like try and get additional money to do two other things, or like spend some of my own money or like my own funding during the PhD to do that as well. But like 1K would be like a significant chunk. It's not just like some small amount and then I'm gonna ask for 20K from someone else or something.
That sounds great. Sorry, just one last thing I would suggest is try to carve out some sort of task to look at biases for the large language model. It seems like a free to do thing given.
Given the models are trained. I want to try a bunch of different stuff, and the bias is generally like, I think there are like automated ways of testing for that, so I'm definitely keen to like look into that as well as whether like these two methods have different effects on that or not.
Sweet, cool work, man. Thanks.
Yeah, thanks for the questions, everyone.
Sweet, awesome, cool. So next in line, we have Jigan, and he's going to chat a little bit about his proposal, the Algovera Academy.
Hey guys, I hope you can hear me. I don't really have too much prepared. I think the proposal kind of talks about a lot of things that are kind of intended to do in the first like sort of month of this. I'm calling it like an iteration of the structures that we're trying to get in place to get the Algovera Academy moving. I have, however, created sort of like a one-pager and 4 interesting sort of like branches that I thought the Academy could look at, like 4 functions essentially that the Academy in my head looks at solving. Of course, a lot of these things I would still say are sort of TBD and need a lot more discussion and time from myself with the community to kind of understand what it is that we're trying to solve exactly, and then kind of build backwards from sort of like a bottoms-up kind of approach. So I'll just quickly share that one pager that I've created. Cool, you guys can see? It should have come up.
Yep.
Awesome. Cool. Yeah, so I mean, these are sort of like the four essential big functions that I thought that in my head, at least, the couple of discussions that I've had with Richard, Hitesh, and Tai, these are sort of things that we thought this could look like. And of course, there's a little more detail on the proposal itself, but the proposal essentially talks about me wanting to kind of dive into all of these topics and kind of start having conversations with the community about these. So one first and foremost is essentially just the funneling of talent. So how is it that, of course, these are conversations I still need to have the community, but how is it that we can kind of create avenues of finding more talent that Algovera kind of seeks? We're already getting, like, I heard Tai say that we got 15 proposals this month, which is great. But how is it that we can find more and more talent such that this becomes sort of more like a perennial approach to finding AI and ML talent and connecting that to Web3? Second is just another thing that I think would be really would go a long way in kind of taking Algovera's name and what it is that we're trying to do here forward by just going into different Discord servers, trying and presenting what it is that we do, kind of create more of a presence, maybe even use some of our Twitter presence to kind of talk about what the Academy aims at doing and keep reaching out. This second point is slightly different from the first point because this may not exactly be the talent that we're trying to kind of bring into the funnel, but it could also be kind of people on the other side of the on the other side of the funnel that are sort of like mentors or teachers that could help kind of take this talent where it needs to be. So those are the two things that I essentially kind of thought blanket large things that the funneling part of the Academy can do. Second is essentially just the learning, which I think a lot of the work here is what needs to be done in terms of just kind of the course material that can be created either on our website or we can find other ways of kind of hosting it. But essential, some of the feedback that some of what I've observed and some of what I've heard others talk about in the community is that while we do have great minds in AI and ML coming to us, like a lot of people who are doing some really good work, there's still a large gap in terms of real understanding of what of how Web3 can kind of catapult or leverage this understanding, and how is it that we can use essential blockchain technology to use this AI and ML expertise. So that's the kind of function that the Academy can do, while it can create like learning initiatives or certain like of course this will evolve over time, but this can create like certain structures or certain course material, sort of like a online course. But of course it's a very cliche, boring term, so of course there'll be more like sort of more dynamic approach to an online course, but sort of like that for a lot of the kind of talent that comes to us. This will of course become a lot more fluid and a lot more tailor-made once it goes through a few sessions of talent going through them. Second being so that's the learning part of the Academy itself. Third is something that I've actually thought of recently through some of the comments that I received on the proposal itself, but this could be a great idea in my head. It's what I'm calling punditry, but it's essentially just like bringing top Web3 influencers to talk about their protocols or the infrastructure that they've created on blockchain. And come and talk to the talent that we have that once a week, if we can do it like in an ideal scenario. If not, bi-weekly, even once a month, have some really smart people come and talk to us about the things that they're trying to do, and how is it that we can start leveraging some of this infrastructure or some of the existing infrastructure for a lot of the ideas that we're trying to build. So that's that third portion there. And fourth, of the most exciting portion, I think it's also the portion where I'd need the most help from the community in kind of building this, would be kind of like the execution phase of the whole of any project that comes to us. So the Academy can create structures around some certain communication and certain set structures around how funds can be brought to projects, how they can start using them, things like that. And the academy can also function as sort of like a single stage, single resource, such that people who are coming to us, like all of the people that are coming with projects to us, don't need to go through a lot of hassle to get all of those things sorted for themselves. So, I mean, in terms of like a large, broad structure, this is obviously what I've come up with like really early. Just spent I would say, just brainstorming in my own head around ideas. And the idea around the first month of the proposal itself is to be able to have more of these conversations with the community and with as many people in and outside the community as possible to kind of get these structures onto the kind of highway, so that we can kind of start developing a lot of these things. Now, in terms of just the experience that I bring to this, I've kind of implemented. I used to work for an organization called Longtail Financial, which was sort of leveraging data and AI, and kind of bringing a lot of sort of like a data AI consultant in Web3. And we were trying to do anything that was themed finance. So what we also had a problem with kind of bringing a lot of projects and people that we wanted to hire on board, because we found out that there was sort of like a 3-month learning period to kind of getting them on the roll or getting them interested by our clients to start getting them paid. So we created something called Netgear Bootcamp, and did something very, very similar to what the academy tries to do here. Of course, thematically, we weren't so much into AI and ML as we were into core finance and a lot of DeFi protocols. So that is what we created there. And about a month ago, it was sort of like an 8-week program. We kind of graduated the first sort of cohort of that, and we intend to do like 3 of those a year. So that's the experience that I bring. I spent almost a year kind of building that, and we ended up getting some really, really smart people on board doing that. Yeah. So, and that's kind of experience that I bring, and that's the idea. Yeah. I'm happy to answer any questions or just even start having discussions.
Yeah, I think this is awesome. I think this is really great. I actually looked on Snapchat, and like, on Snapchat, there are votes for this already that are, so I really think the community like wants to see something like this implemented. Yeah, I definitely really agree with the Web3 onboarding. I think like this is and can be like data scientists, machine learning engineers' first step into Web3 through Algovera, which means like we have an opportunity to make like a great impression in that area. But yeah, those are some of my thoughts. I would love to like hear what everyone else has to share.
I think that a lot of things that might be useful is if you have a portal like a wiki where you can have individuals drop tips and tricks, and then those tips and tricks can get turned into short form instructional material, so that when somebody on, for example, Reddit, right, is talking about this new subject, like I'll use a real subject I know that my friend Lucas found out this method called True Grad, which is more efficient than the Adam W method, and he's been discussing it. He's been discussing it with John Carmack on Twitter, right? So I can put that information into a wiki, and then somebody who's good at technical writing can turn it into a short form blog post. And now, all those charts that came from Twitter and all the explanations from Twitter are condensed into something that somebody can use to improve their own code.
Yeah, I think that's fantastic. Like Wiki, I mean, I've initially worked a lot with like Notion. I think Notion's really, really powerful too. But yeah, Wiki works. There are a couple other. I mean, the platforms can of course be. We can start deciding on those platforms. But I love that idea. I think the first month of just going through what is that I would need to do in terms of kind of setting up the right frameworks for the academy would be exactly on those lines. So yeah, thank you for that.
Swapnil, you got your hand raised.
Cool. I just wanted to ask if you have thoughts on when you start funnel, like creating this funnel and like improving the sort of reach that Algovera has, do you also envision requiring the grants to scale with that? Like having 10 grants out of 15 grants is different from having 10 grants funded out of 150, assuming we get to that level of scale. So do you think there's a roadmap to be laid out for that, or will that be necessary? Or
I think that's a really good question. I mean, I think the answer to that is we try and leverage these connections that we're trying to build through the academy itself to get more funds on board, and then we kind of create structures around how is it that we want to disperse them. But I think the idea of the academy itself could be a product, and if we were able to kind of bring sponsors on board, that could help eventually. Of course, if that system itself is well sorted, I think that system brings with itself some level of influence and monetary kind of benefits that we can use to kind of start leveraging ideas. Of course, it's not always that funds is something that Algovera can kind of start becoming the mediator for. We could always just we could have better mediation around just getting the right people connected to the right people. And even if that's something that the academy does, I think that's a very novel idea. If we get the best, for your idea, if we can get the best people in the world that are talking about that idea or have already implemented similar stuff, I think the academy could be a great point to kind of leverage that connection too.
I think that's a great suggestion, actually. Like creating a talent community might be a very good value add, as opposed to like just linearly trying to scale grants, because that's much harder to my understanding,
Of course.
especially in the current funding climate.
Absolutely, yeah. So like we will always have climates like we're having right now. So my vision for those periods is to be able to just bring the right people to kind of come on board and be as passionate about the ideas you are. I've in my experience also learned sometimes that just having some people ask you good questions around your idea can kind of push you. And sometimes that's all we need. And if we can get some people to do that, if we can get, I actually spoke to some really smart people around who are trying to create some learning initiatives around Web3, and a lot of them are just doing it right now with just sweat and blood. So that's the way this world is working right now. While I'm not trying to say that just getting funds is something that we're not going to try and do. If we can get the right infrastructure, suppose a good protocol really likes an idea that Algovera is talking about, I'll be super happy to kind of use those community events to start leveraging relationships such that they can have the right monetary attachment to. Yeah.
Sweet. Thank you.
Awesome. Any other mentions or questions? Sweet.
Okay, thank you guys.
Awesome. Cool. So next up, we have Swapnil, actually. Excited to hear what you got.
I'm just gonna walk through. Sorry. Could someone confirm if they can see my screen?
Yep.
Okay, perfect. So I'm just gonna talk about the last grant proposal that we got, the sort of product that we were able to build based on the proposal. So the problem we're dealing with here is like Facebook and Twitter and like 100 other companies publish these things called transparency reports. So if you go to these websites, transparency.twitter.com or transparency.facebook.com, you'll see that they have a bunch of transparency reports around like what they found on their platform, like the coordinated activity, the takedowns, the actions. Like one key part of this is taking down networks of accounts that aim to mislead the public about some sort of topics of interest. A lot of times these topics of interest come up in times of civic volatility, elections, sort of major civic events around protests, around wars. And we've seen this happen quite prominently in the Russian invasion of Ukraine. We've seen this happen in the Iranian protests. We've seen this happen in a bunch of other situations, particularly the US election of 2016, and then the midterms, and then like the US has been like particularly at the forefront of fake news sort of influence. And so a lot of platforms started this thing where they release like information on like we actioned on these billions of accounts, and we removed like hundreds of networks of accounts. And they even started like to their credit, like they started publishing metrics quite openly. And only this year, I think, this year they started giving access to more researchers, but they did start publishing some data around this. The key challenge around this kind of activity is like we see this nice graph about them actioning on billions of accounts, but we don't have any idea what the upper bound here is. And what's more important is they don't either. And I know this because
can I just bump in here? I don't
yeah.
know if you're intending to share the screen, but we can't. We can only see the
Oh,
gathered
my
hand.
bad.
Yeah.
Oh, oops. Sorry. Let me double check. Sorry, is this visible now?
Not yet. No.
Yeah, not yet.
Oh.
Connecting now, I think. Yeah. Okay, we can see it
Okay. Thanks, Satan.
Oh, okay. Sorry. My bad. Yeah, thanks for jumping in there. So what I was saying was these sites publish transparency reports, transparency.facebook.com and transparency.twitter.com, and they publish all of these nice plots about like we action on like billions of accounts. And there are neat metrics around like all of the work they're doing in this space. And to their credit, like the teams are doing a decent job. The plot I'm talking about is this kind of plot where they like, oh, we action on millions of accounts over all of these time periods, but they have no idea what the upper bound here is. So we know that they took down like a network of 100, 200 or 300 accounts, but like we don't know like how many networks there were on the platform. In fact, they have no idea either. And I kind of know this because I worked for Twitter last summer. I kind of have contacts at Facebook for working on these kinds of things. They invited me to give a couple of talks, and we're working on a sort of partnership in a couple of months. So the work we started doing with the first grant we got was to try and build a system where for journalists to track what the impact of news online was. So one of the easy ways to sort of get lost in discussion is to try and debate whether news is fake or not. And we've seen lots of people go down that rabbit hole of, is this fake news? Is this not fake news? Is this misleading? If it's misleading, should we action on it? Should people be banned from platforms? Like what actions should we take, and so on and so forth. We tried to avoid going down that route with like a discussion of concrete metrics around the spread of news. So from our perspective, what we're looking at is this kind of network that is spreading 3 articles of interest. So one of there's like the network in blue, which spreads the article directly. So this is a real Twitter network with data obfuscated for privacy reasons. So in blue, you have the accounts that are actively spreading these articles. In yellow, you have like accounts that follow some of these blue accounts. And in green, you have accounts that follow some of these blue accounts and engage with a lot of blue account posts. And we started out with a bunch of articles from these 2 Russian outlets, Sputnik and RT, Russia Today and Sputnik News, which have been very clearly established by a bunch of different organizations like the European Commission, Meta, Twitter, the State Department, like academics. Like basically a lot of studies have been conducted around them being the pillars of disinformation for Russian information operations. So we sort of know that while they don't lie actively, they do promote a lot of misleading narratives very frequently. And this activity was made quite clear to us from like looking at activity during the Ukraine war. So I'm just skipping a bunch of things here. But on the sort of y-axis here, you see there are a bunch of account IDs. On the x-axis here, you see like a bunch of articles. And so this heat map represents like how often a group of accounts share a particular article. And this is chronologically ordered. So on the left here, this is like 2021. This is the later half of 2021 and early 2022. And this bright sort of squares show you that like there was a ton of activity around sharing RT and Sputnik articles by a bunch of accounts on Twitter that tended to share these articles. So it's like sleeper accounts being activated, and suddenly like lots of accounts are very frequently sharing these articles. And we use this to kind of detect like these small clusters of accounts that are overall engaged quite frequently in sharing a bunch of these articles. And the reason we focus on sharing is because that's a binary decision you make to share or not to share. Like there is no debate around like, oh, this account may or may not have shared this. And so that allows us to create like quantitative metrics that are like not like fake news, whether this is like your opinion on a news article being fake or not. So what we try to do is like study. So we've created like a big data architecture. So we mine tweets from Twitter using a bunch of API keys, store it in BigQuery, do some processing on it, put it in a graph database on Google Cloud, and we have the ability to run these queries super quickly to like figure out in the first 5 seconds of RT or Sputnik posting a tweet what 100 or 200 accounts or 2,000 or 2,000 accounts actually retweeted it. And with this like 5 second question, like what we're really trying to get at is like there are automated accounts that are just reposting these things, and those networks have been active for like years, and we have like quantitative evidence on this. Like this is a plot, for example, of like the year that this account was created, and these are all of the accounts that have engaged with or shared like or posted a tweet that like that involves multiple RT and Sputnik URLs. So sorry, multiple tweets that involve an RT or Sputnik URL. So you can see like here on the x-axis, like these accounts were created pretty early on, and on the y-axis we have the log number of followers. So this is, and the circle size or color also indicates like a bunch of followers. So while this big yellow dot is like the official account, so they have a ton of followers on the official account. There are also like a ton of other accounts that are reasonably influential, and I would argue collectively way more influential than just the official account, that are actively spreading these kinds of tweets. And so like we're focusing on this part of like sharing that is sort of very obvious, or should be made obvious to the public, that we can track externally in order to audit the spread of news on the platform. And we got like a sort of partnership with the Times in the UK through a fellowship for journalism and AI to build out this platform that I was showing you before. We were trying to gather a bunch of metrics, not only around like the networks, which are super expensive to get from a time and cost perspective on Twitter, but also like the toxicity of these tweets. Google gave us like an extension on like a bunch of APIs they have to measure toxicity using large language models. So we have like day on day, what was the amount of spread of this tweet, what was the toxicity of the average tweet that was spreading these URLs, and then metrics around the trends of how many tweets per day were being shared for specific articles, and then the trends on toxicity, which is like day on day, what was the toxicity for the discourse. And we were also like figuring out like how do we apply language models to propaganda detection, state of the art language models at the point in time. And we sort of arrived at like we want to focus on coordination and coordinated behavior. And so we're working on like a single dashboard wherein a journalist can come in, give us an article URL, and we track like how it's spread across not only Twitter but a couple of other platforms. So Meta and Reddit and Instagram, to be precise. So we're starting there, and then we want to sort of expand horizontally to a bunch of other platforms. So so as to create like a discussion that is less arbitrary than is this fake news or not. We aren't fact checkers, but we know that fact checkers would benefit a lot from the system. We've spoken to them as well. So the Wikimedia Research Foundation has been in conversation with us to sort of discuss how we can use this to help whatever fact checkers they have or whoever is posting source links on Wikipedia, to automatically measure like this is the impact this source link has had on social channels in real time. So something like there's this index of news called IFI News, and this person basically maintains a list of credible or non-credible websites. And again, that sort of goes into the direction of opinions on or perspectives on whether a news site is credible or not. But the fact that we can track how much a news site has spread online and the networks that have spread it gives us a lot more quantitative evidence to make that decision. And we don't just rely on like someone who like someone telling us whether a news site is credible or not. So anyway, the whole focus of the project is now to start creating public auditing dashboards to study like how this content is spread online. Luckily, we've been able to create an architecture to do that. So now it's just a question about scaling this, looking at different platforms, getting access to different data sets, and to continue building it out. And so
Quick question on the technical side. You mentioned that you were essentially lining the tweets from APIs, putting it into the query, and then you mentioned the database, the graph database. What particular one are you using?
So we started with Neo4j,
Okay.
because that's available on Google Cloud, and we found latency is pretty low for I think 85,000 accounts and 64 million tweets. So the edges are about 78 million, if I remember correctly, and the queries run in like seconds, so it's pretty reasonable.
Exactly. Yeah. Cool.
Yeah, this is a bunch of students that I've worked with over the past few years who are also helping me with this project. So yeah, that's it. Thanks.
I have a question. So when you are detecting users that tweet RT, I noticed that you have like one graph, which is I think a timeline of people, how old their account is over how relevant they are. And I didn't really see anything that appeared to be like a pattern from that. And then I saw something about accounts that follow other accounts that have like, let's say, a high number of, and are you trying to measure a high number of self-referential or in-groups, like in-group following behavior? And I guess kind of the notion that I have is that people do actually have ideological bubbles. So, you know, like I think that if you were to instead say like use as a proxy groups who who liked articles or linked to articles that thinks that the Iraq war was a good idea, because many people have found this to be, you know, misinformation about yellow cake uranium, many things about misinformation regarding, you know, U.S. war crimes that may or may have not happened, right? And then it seems to me like in some ways, I know that the European Union says RT is misinformation, but it's just, I think that you're going to end up with a lot of false positives of just people who are just happening to wanting to be in that bubble. I want to be in the RT bubble. Now all of a sudden I am labeled as a bot, for example. That's the problem that I see. And I know that there's some new laws coming out in different states of the U.S., for instance, Texas, which says like, oh, these platforms cannot ban you based upon your viewpoint. That's like a social media law found constitutional by the U.S. Court of Appeals. So the question is, how do you minimize the false positive rate of people getting caught up in these automated filters just because of their viewpoint?
Absolutely, that's an excellent question, and I think that was the entire reason like we started looking at like the time to sharing for accounts that reshare RT and Sputnik articles. Like the reason we imposed a 5-second sort of limitation was because we found that that gave us like, and I don't have the plot here, but that gave us like a peak in number of accounts that were very quickly retweeting like RT and Sputnik. So
yeah, but hold on. So if you're running the Twitter app, right, you run it and you can either do the preferred thing on your timeline or literally the latest tweet. So when you have it set on latest tweet, the first thing that's on your phone is the latest tweet, and people impulsively just push buttons. So they just click, oh, I like that, retweet, and now they're on this list.
I agree, but doing that 17 times over the course of 30 days, RT tweets at different times. So we've looked at like, we create a system where you look at every timestamp for RT tweeting. It's not the same time per day. So it's at different points in the day, and these accounts are retweeting that in the first 5 seconds at different points on each day, which is either implying like they're it's extremely like unlikely that this is organic activity. Like if I tweet, you at least take like 5 seconds to read an article headline or like go read the article or something of the sort. Like if you do that 17 times in 30 days, that seems like oddly close to inorganic activity. And The second thing is we try to further study, like we use this to source a network that we want to further study. So we don't really label them as bots. We just give them to the journalists to study further. In terms of these, so there are all of these organizations publishing reports around coordinated activity. And one of these is the Stanford Internet Observatory, which studied India, where I'm from, and like a bunch of Indian origin actors that publish, like try to push a certain state-backed narrative. And what they try to do is study like these sorts of networks, or source these sorts of networks, and then study what else these networks are sharing. So what we're trying to do is like study if these networks that we're sourcing are sharing the similar types of hashtags, and like what other narratives are they promoting by hand, so that that is not an automated sort of detection system, but rather a system to source some signal from a lot of noisy posts and noisy accounts on social media that can then be studied in like by a team, by researchers, like by hand basically, instead of automating all of that detection. Because the automation part really comes in when you have billions of accounts that you can't study by hand. But when you have like hundreds of accounts, you can easily study what they're sharing by hand. So we collect like the last 200, 300 tweets that these people have all put out, and aggregate those using a bunch of techniques to create like a system where you and I can go in and like study what is going on in these accounts, what is the kind of activity, and like then there is a discussion to be had about whether we think these are organic or inorganic accounts. But that step of sourcing the signal from noise is super important to try and create a high likelihood system for detecting automated activity. And also,
Okay.
so this is scientific evidence. There is scientific evidence for this. Like there are libraries that do this used by Facebook that we've appointed to as well. So that's part of the reason why we think this system should work. This is CoreNet. This is like a library used by Facebook's integrity team, or at least referred to us by Facebook's integrity team as a public domain tool that also does the same thing. To summarize, if you ping me, I can share all of these links with you. But yeah.
Cool. This is super fascinating. Thank you for sharing. Yeah, your project is awesome. I want to go to the next one. Desparto, are you there? Would love to hear your proposal and what you got going
on. Can you guys hear me?
Yes.
Right. So let me just share my screen. Can you confirm the screen is sharing?
It is?
Yeah.
Yeah. So like my presentation, the project I'm working on is quite simple, I would say. So it's about like extending the stable diffusion prompts using text generation model. So like if you in stable diffusion we are like prompting things, so that turns into images. So there is a basic structure for a good prompt in stable diffusion is there is a subject like here like a scary ghost standing next to a bed, and there are these all of these style cues. So there is night, moon, integrate, detailed, concept art, all of these style cues. So like the it's like a prompt engineering technique to add these because of the data, because how the data was labeled on which stable diffusion was trained on. So like there are all these style cues that makes the image better, like trending on ArtStation. So uh, like and to generate these images for someone like me, I could come up with something like this scary ghost standing next to a by, but I couldn't like come up with all of these like style cues to like better my image. So what this project is doing, like so we are using text generation model. So we give it a subject like an ancient moon, and uh, okay, so then we submit it, and okay, so it adds style cues to it. So like it adds this by Greg Rogoski. So like he's a very famous artist, and like he's the the most mentioned artist in Stable Diffusion prompts, and there are all of these like different style cues that are added to this. So for the project, I trained a new tokenizer on the data set of Stable Diffusion prompts, and then trained a GPT-2 model on it. So like I trained a new tokenizer because like the pretend one was butchering the artist names. Like if you could let me just load this one here. Right. So okay. So we have this prompt. So this is one of the prompts from the data set with all the like style cues and the subjects. So like the old tokenizer was doing this beauty full, like it was butchering things up, and if we see an artist name like this, so it was here, so it was breaking it into different pieces. So and like when I trained the tokenizer, a new tokenizer from scratch on the dataset, so it parted the artist name into right correctly. So that's why I am using like a new tokenizer for this. And so after that, there's the GPT model that I trained for this. So and like currently what I'm looking into is right now we are just using basic GPT-2 architecture. So what I would be looking into the future is like doing other architectures, more bigger models for this, like GPT Neo X or maybe Bloom. So and like making better data set for this, yeah, like scraping Lexica for all of these prompts, or doing stable diffusion, from the stable diffusion Discord server. We could scrape these prompts. So that's something I would be looking into. And yeah, I think currently that's all we have for this project.
I think that's a good job, and I know there are bigger models. I can lend you whatever compute I have available, and then there's like the Tensor Research Cloud. Get rid of the Tensor Research Cloud.
Right, yeah.
I think that I know some people over there that can give you some compute to train a bigger model like Neo X.
Yeah,
yeah, I mean,
yeah, like currently I'm like GPT-2 is I would say quite small from current standards. Like there is
yeah,
GPT-3 and like GPT-4 is on the horizon. So uh, but yeah, like GPT Neo X, it's like 20 billion. And so yeah, training would take compute. And so yeah, that was a good suggestion, thank you for that. And another thing like I would like to share is like recently some people from Stanford uh, published this this huge data set of like 14 million images and prompt pairs. So like this is something we are like experimenting with and exploring these data sets so that we could leverage it more into the project. So like there are like 1.8 million unique prompts, which is like 10 times the one we are currently using. Sorry, someone was
on that data
asking.
set, can you go through the table real quick?
Yeah, right here.
Does it have like an aesthetic rating? Do you know what I'm talking about when I say aesthetic rating?
It doesn't. For aesthetic rating, no, it doesn't.
Okay. I have a very easy script that you can use. It's really, I think, open source or something, which you can use to enrich that data to get how good the image looks. And maybe you can use that to...
Yeah, aesthetic scorer. Sorry.
Okay.
So like currently I have another person on the team. Like we met on Reddit, and I posted about this project on Reddit, and he was very interested in it, and he reached out to me and said like we could work on this together. So currently him and me are like exploring this data set and doing experimentation with the other architectures. And we are also thinking of like leveraging other sorts of like currently we are just doing plain text generation, but something we are also looking into is like taking subject recognition. Like if the subject is a landscape, we wouldn't want a style cue like a clear eye, but if it's a dog or a person, we would certainly like a style cue like a clear eye or symmetrical. So yeah, that's something also we are looking into. um,
Sweet. Um, Thank
and
you
yeah.
so much for presenting today. This is pretty epic. And yeah, I don't know. I'd like to, we have our final presenter, Alexi. If you're here, and you are, would love to, yes, see what you got going on.
Yeah, so I'd like to present the, let me share the screen. Can you see my screen? I don't think so.
Yeah, I see your screen.
Yeah, that's my screen. Awesome. Yeah. So over the last month, I made this library called Audit, Tensors. Maybe some of you have seen it. It pretty much lets you visualize what's inside your tensors, because normally, if you get a bunch of data in PyTorch or in any other machine learning framework, you want to look inside and you just dump it to cell output in Jupyter, and you see things like this, right? It's a bunch of numbers, which is not super useful for a human. Like I want to see like, what is the scale of those numbers? What is like mean and standard deviation? Maybe if there are any bad numbers like nans or plus minus infs, and also have an easy way to just visualize. Like, is it a, so this looks like a 3 dimensions, maybe it's an image, right? So this is exactly what Audit Tensors allows you to do. You input your monkey patch, your PyTorch class for tensors. You don't have to. There's another way to do it without monkey patch, but that's the way I prefer to do it. And after that, same prompt pretty much gives you all the info you want. Gives you the it's free by 96 by 96. So problem image. Gives number of elements, the range, mean and standard deviation. If it's like if you just a few numbers, then it will also print out the numbers. Also show things like plus minus infs and nans. So it will highlight those things, so you immediately see that there is something wrong going on in your code. If it's all zeros, it also will just tell you it's just a bunch of zeros. And it has a whole bunch of other things. You can like unfold it so you can see all the 3 first dimensions or even more dimensions. Also lets you pretty easily visualize your things. If it's an image, you just put RGB. It's an image, right? Well, it's been normalized for ImageNet, so we want to denormalize it easily. Just pass it the stats, and here's your benchmark. Also lets you plot the statistics and visualize individual channels and channels in a convolutional neural network. Lets you group things. So this is a tensor of 8 images that are stacked 2 by 2 by 2. And here they are. And that's pretty much what it does. And I would like to use the next month to implement this library also for JAX and for NumPy, which is something I've been doing. Over the last week. So there is also some progress with the NumPy and JAX, but it's definitely a lot less developed than the PyTorch version. That's pretty much my request. And if we have time, if you guys would like to see, I made a short demonstration of how I dissect stable diffusion, go inside and look at all the things that are inside stable diffusion using this library.
Yeah, that'd be nice to look at. Thank you.
Awesome. Yeah, let's go.
Sweet.
So I'm not sure how many, it sounds like at least some of you are very familiar with how stable diffusion works. So I'm not sure I can explain all the parts, but at least the main parts. So I think the previous presenter talked about the text encoder that they are going to train. So it pretty much brings things from a prompt to a vector form. So it's this part that they want to train, right? It's the clip encoder. Another major part of this thing is a variational autoencoder. And it's a pretty the thing. It actually just takes an image, a big image. It compresses it to a much smaller image, which is like if it was 512 by 512 with 3 channels, it compresses down to 64 by 64 by 4 channel, which is about 50 times reduction in size. And then it uncompresses it. Just from this thing, it comes back to the pretty much look like original one. So it's this part. It lets you, for example, start with an image and use the starting image. Or on the output of the model, you also get like a latent presentation of what you want to see, and it lets you get a more human readable image from it. That's bigger. And of course, the other part is the UNet, which predicts noise. So how this thing works, you will have this compressed image that is 64 by 64 by 4 channels. You fill it with noise. You pass it through the UNet together with your prompt and a measure of how much noise you added. And the UNet is going to predict the noise. They actually have a trick that's used to improve quality. It will both predict the noise for your prompt and predict the noise for an empty prompt. So you do a bit of math here so that you're trying to predict the noise that is more correlated with what is in your prompt, right? And you use this noise to subtract a bit of noise from your image, and you do it a bunch of times, and hopefully in the end you will have something that matches your prompt. If it doesn't make a lot of sense, I'm not sure if I can explain it much better in just a short time. But we can look at the code. Hopefully, it's going to make a little bit more sense. So, luckily, we don't have to write everything. That there's like a ready-made library that does most of those things, but we still have to put them together. So we input those things, we input lovely tensors, utility function to plot stuff nicely, and here's our variational autoencoder. Here's a tokenizer and text encoder, which are both taken from clip. The UNet, and another thing is the noise scheduler. Basically, like in this thing, we have a key that kind of represents the amount of noise, but we don't want to do like 1,000 steps. We want to be able to just give it like a few values for the noise that is less than 1,000. So let's jump in. Here we load an image of a JPEG image converted into a tensor form. It's size 512 by 512, and we get a tensor, right? 3 channels, 512 by 512, values from 0 to 1. We can it looks like an RGB image. So, if we pass it through VAE, we have to scale it. We have to multiply by 2 and subtract the mean. But basically, we pass it through the VAE encoder. So, not the cell. Yeah, so we run through the VAE, and we got 4 channels, 64 by 64. If you want to have a look, Just do chance. Scale, it's a bit small. Let's do 5. So this is what the image has been turned to, but it's actually like much smaller in size because it's only for small images. And to decode, we take this latent, which is 64 by 64 by 4. We pass it through VAE decode, and we get back our 3 by 512 by 512. That is very, like, I'm very impressed by just how you're able to compress it down to such a small size and only this thing. And in the end, if you look at it, it looks almost the same. If you just look at two things, maybe you can look at the eye of the bird and see that it looks a bit good, but otherwise, like, it looks like a very good image. So here, hello.
Yeah.
We're here.
Just checking if I'm still online.
Yeah.
Absolutely.
I don't know if it's possible that you could, for instance, highlight a word in your prompt and get out like the product of how much that word has actually influenced a tensor or value going into one of the levels of the neural network. You know what I'm talking about?
I mean, yeah, I understand. I'm trying to figure. I think it's like pretty much you have to do forward differentiation. So you pretty much just give your network two values for the input, one with the original word and one with the modified word, and see how then the values of the output or the intermediate values change depending on this word. Yeah, totally possible. I mean, it's not like a built-in in this library functionality, but it's something that can be done pretty easily. Yeah. So here. Sorry.
Sorry. Maybe because I have a very similar question. Use of monkey patching makes me think that you're from Fast AI community. Anyways, the question is like very similar. Like, are you planning to inbuild things like GradCam in this to observe the gradients as well? Probably that would allow you to see how the gradients changes versus when you change the prompts.
Yeah, I feel like things like GradCam. GradCam is this thing that highlights like your patches on your original image, right? If I remember correctly. Yeah, basically. Yeah, you can totally use this library to make it much easier to build something like this. I don't think it's going to be like a built-in function because it's a bit of a balance of how generic this library should be and what should be the level at which this library operates, right? If it should be more like high-level stuff or more low-level stuff. But yeah, I definitely could think about this. And I had GradCam and a few other things in the back of my head. But yeah, you guys want to continue with the presentation? Or are there other questions? Well, there are no other questions. I'll continue. But yeah. Here I'm looking at the diff. I'm just subtracting one from the other and adding minimum so we don't have negative numbers in the RGB because that just doesn't make sense. And yeah, there is a bit of a difference, but it's not that big. Here are some functions to just make it easier to encode and decode. And just to check that they work, I encode the image and then decode it and then see the RGB of it. And it's the parent. So the next part of the thing is the encoder, the text encoder that takes us from the text prompt into this vector space, right? And let's just look at the data that goes into it. So if you have a bunch of prompts like my cute cat, my cute dog, and a photo of a pasta on a plate, you can run the first part is the tokenizer, and it takes a text, right? It takes the prompt, and it outputs a bunch of numbers. And let's see. 1, 2, 3, 1, 2, 3, 4, 5. Right? I'm not sure what they mean. The other one, this is the same, this is the same, this is different, right? So it must be a start token and end token. And this one stands for my, this one stands for cute, and this one stands for cat, this one is dog. And I guess path is going to be a bit longer. Yeah, that's correct. So if we want to actually feed those tokens into the text encoder, we have to give it the length of 77 because that's what it's been trained for, and pad the rest of the string with this end of input token. Yeah, that's what we get. Again, to get better results, we want to use also an empty string, an empty embedding. So I'm passing two things, and I'm on the output. I'm also getting like a batch of two vectors, length 77. So that's the pasta vector, and that's the empty vector. Embeddings, they convert those two vectors into two matrices. So we have two, and the size of them is 77, which is the length, if you remember, and that's 768 is a vector that corresponds to each word. It also has position information. If you want to look inside, that's what they look inside, all right? So as you can see, the first one, with the pasta, like those things, like each line corresponds to one word, to one token, sorry. So the first two lines have different values, and the other lines, they don't look like they change slightly, but they kind of look the same, right? Because we have all this end of line token, and they change because the embedding also contains position information for each word, right? Because otherwise you wouldn't be able to tell if it's the word in the beginning of your sentence or in the end. So all those changes, all the slight changes in the brightness here, they encode the position of those tokens. Now we pretty much have all the components of this system. Right? We have this part, we have this part. We generate a bunch of random numbers that are of this shape, like in latent space of 64 by 64 by 4. We scale them. There's another thing that's missing from here is the noise scheduler, because you want to be able, you want to scale the amount of noise that you pass it with. That you want to tell the model more or less how much noise it should expect in the input, and this number is scaled by the scheduler. So generate a bunch of numbers, send it to the CUDA device, and scale it a bit down, right? So 464, 64. That looks correct. This is the range of it. I don't know what the range should be, but it must be correct. And this is what it looks like, right? Just a bunch of noise. And yeah, there are 4 channels. Each of them contains noise. And if you look, remember, this latent noise is in this 464 dimension. And if you want to look what it would look like if we decoded it into RGB, that's what it would look like. It's not exactly like just noise, but it's also nothing that really looks like something you would recognize. So a bit of a dive into the scheduler thing. So we asked it to do 50 iterations, right? To plan for 50 iterations, and it gave us T's. This is the value for this T that goes into the network that kind of corresponds to the amount of noise that it expects to see. So on the first step, it expects to see a lot of noise, and at the last steps, it expects to see a lot less noise, and the value for noise scales between 0 and 1,000. So let's set t to the first timestamp 0, and we have to scale our input according to this noise, and also we have to pass two images, right? Because here only one image, like here we only have one image, but we have two prompts for it, right? So we have to duplicate it. That's it. Calculate predictions. This will calculate two predictions for the noise that the network that the unit will predict.
Alex, is your model open for others to play with and see?
Yeah. It's not. It's just the standard. Like it's just the stable diffusion model from Hugging Space.
Okay.
Like it's not nothing special. If you want to see like a more like in-depth walkthrough, it's based on this stable diffusion deep dive by Jono.
Yeah.
Yeah, you must have seen it. Like some of the examples. I'll take it from here. This thing goes a bit more in depth. It also explains things like dream booth and some funny things, like if you like do things like if you tokenize like a mouse and a leopard, and then take the embeddings and take the average, then this is what you get. Pretty impressive, I would say.
Sorry to chime in there, but like I'm also doing the fast AI part 2, and like for learning more about this, like the first 2 lectures are available.
Yes.
So like you guys could check that out.
Yes,
And yeah,
absolutely.
awesome work on this lovely tensor. Really.
Thank you. That's the thing is like there's not really much left. Like if you look at almost all parts of this thing, right? There's not that much to do. The predictions. Does anybody want to tell me what is going to be the shape of this of predictions? Okay, let's just regulate. So it's 2 because we are trying to predict for both with prompt and without prompt, and 464, right? If you want to have a look at what they look like, they just both kind of look like noise. So we split them into 2 things. This one is wait a second. I have made a mistake here. U and P. Yeah, it should be P and U. So this is the predicted noise with prompt. This is the predicted noise without prompt. And we want to make a prediction that kind of points more to like it scales the part that predicts noise from the prompt in a positive way, and it scales part that corresponds to predicting just noise without a prompt in a negative way. And this is what this formula does. So we have predicted this noise in the latent space. It doesn't really look like a lot, right? We can do EAE. Look like what it would look in the RGB space. Doesn't really look like pasta yet, right? We want to update the latent noise because we have a step-up scheduler, so it's kind of similar to what an optimizer does. It takes the predicted noise, it takes the T, and it updates the latent noise. It's still not faster, right? The thing is, we have to run this thing for, like, we told it that we want to run for 50 steps, right? So initialize it again from 0, and let's run it for those 50 steps. 50 steps done. If you look at the noise in the latent phase, a little bit faster. Let's try to decode it. And it actually looks pretty delicious. That's all the magic, like, that's it. Do you guys want to play with some things in here? I can, like, if I don't think there's anybody else presenting after me. So if there's interest, we can change things here, or I can also just upload it to GitHub and you can play on your own.
Yeah, this is pretty awesome. I don't know if you regularly do like workshops, but I think you know, I don't know if you've done them before or if you want to do them in the future, but I think that's all of this is pretty epic. And yeah, we have a stable diffusion channel. I don't know if you want to post it in there. You can.
Thank you.
Yeah, and yeah, truly awesome stuff. And this is this was our last presentation. It's about 8:30. I don't know what that converts EST. I'm not sure what that converts to. Maybe like 1:30 p.m. UTC. But there was a lot of good proposals, a lot of good projects. Just some like updates on my end to kind of wrap up is we're in the middle of the voting phase, right? So we have until the 23rd to vote on all of the projects that you see here today. And of course, we have more on the forum. And yeah, super excited to see which projects get funding this round. There's a lot of good stuff shared today. And yeah, is there, before like I kind of wrap it up, is there any questions that anyone has for anything at all? This was a lot of fun.
Thank you, everybody. Thank you for sticking around.
Thank you for giving us the chance for presenting our projects.
Yeah,
You all.
absolutely. Thanks, Alex. It was awesome.